In Chapter 7, we're going to be dealing with rational functions. And anytime in a math class you see the word rational, you want to think of fractions. A rational expression is a fraction with polynomials in the top and the bottom. One basic example would be something like f of x equals 3x minus 5 over negative 2x plus 1. So suppose we have this function and the problem asks us to find f of negative 2. What that means is we're going to need to substitute a value in place of x everywhere there's an x in that function. And the value that we're going to substitute in this case is 2. Now, when you're simplifying rational expressions, you want to simplify the top part as much as you can, simplify the bottom part as much as you can, and then try to see what the final answer would be. So here, looking at the top, 3 times 2 is 6. 6 minus 5, we would get 1. On the bottom, negative 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So negative 1/3 would be the answer. For the next one, f of negative 1, we start out exactly the same way. We're going to be replacing x. Everywhere there's an x, we're going to replace it with a value. In this case, the number we're replacing it with is negative 1. So on the top, 3 times negative 1 is negative 3. Negative 3 minus 5 is negative 8. On the bottom, negative 2 times negative 1 is a positive 2. 2 plus 1 is 3. So we get negative 8/3. Now, what we're going to focus on here in section 7.1 is reducing fractions. If you think, for example, of a fraction like, say, 12 over 20. To reduce a fraction like that, you divide the top and bottom by a common factor. In this case, 12 and 20 are both divisible by 4. So you would divide them both by 4, and you would end up with the lowest terms, which are 3/5. We're going to do the same kind of thing when we've got all these variable expressions. We're going to try to find common factors of the top and the bottom. And we do that by factoring the top as much as you can, factoring the bottom as much as you can, and then seeing if there's anything that we can divide them both by to reduce it. Let's look at our first example, 4y plus 2 over 6y plus 3. On the top part, the first thing you always look for when you're factoring is a common factor, and those terms are both divisible by 2. If I factor out a 2 on the top part, 4y divided by 2 is 2y, 2 divided by 2 is 1. Now on the bottom part, looking at these terms, they have a greatest common factor of 3. I can factor out a 3 from those terms. 6y divided by 3 is 2y, 3 divided by 3 is 1. So having factored the top and the bottom part here, I can see that there's one factor that's the same on both parts. That's the 2y plus 1. So I can divide the top and bottom part by 2y plus 1, and all that we're left with is 2/3. That's how we're going to work through the problems in this section. Factor the top part as much as you can, factor the bottom part as much as you can, and then reduce by the common factors. So let's look at our next one. X squared minus 4 over x squared minus 5x plus 6. So first, focusing on the top part, that's one of our difference of squares problems. The square root of x squared is x. The square root of 4 is 2. We put a plus in one group and a minus in the other group, like so. Then for the bottom part, we need to figure out what we can multiply to get a positive 6 that adds up to a negative 5. And that would be a negative 2 and a negative 3, like that. If you check it, negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. So that's the way to factor that one. Now looking at these, we're looking for something that's a factor of both the top and the bottom parts. In this case, there's an x minus 2 on the top and the bottom. So we can cancel those out. And what we're left with on the top is x plus 2. On the bottom, we're left with x minus 3. So that would be the answer for that one. Let's try this same process on our next one. Here we have 4x squared minus 36 over 2x squared plus 14x minus 60. So remember, the first step you always try to think of when factoring is a greatest common factor. On the top, looking at 4x squared and minus 36, those are both divisible by 4. So I'm going to start by factoring out a 4 from both of those. 4x squared divided by 4 is x squared. Minus 36 divided by 4 is minus 9. On the bottom part, looking at all three terms here, those are all even. They're all divisible by 2. So I'm going to factor out a 2 from all of those. 2x squared divided by 2 is x squared. 14x divided by 2 is 7x. Minus 60 divided by 2 is minus 30. So for right now, I'm going to leave the 4 where it is, and I'm going to leave the 2 where it is, and I'm going to try to factor what's left on the top and the bottom part. On the top part, we're left with x squared minus 9, which is another one of those difference of squares problems. The square root of x squared is x. The square root of 9 is 3. I put a plus in one group, a minus in the other group. On the bottom, I'm trying to think, what can we multiply to get a negative 30 that adds up to a positive 7? And the answer would be x plus 10 and x minus 3, like that. So let's take a look now at reducing this one. The one thing we see that's on both the top and the bottom is x minus 3, so we can cancel those out. Now let's take a look at those numbers at the front. We have a 4 on top and a 2 on the bottom. You can reduce those just like you do regular fractions. 4 and 2 are both divisible by 2. So we'll reduce it. 4 divided by 2 is 2. 2 divided by 2 is 1. So what we're left with on the top is 2 times x plus 3. On the bottom, when you have 1 times x plus 10, you don't really need to put the 1 there. You can just put x plus 10. So this would be our answer. And it doesn't matter. I usually leave the parentheses there just to remind myself I have to treat that x plus 10 as a group. I can't reduce part of it or anything. Let's take a look at the next one. This one can be a little bit confusing to a lot of people. X minus 2 over 2 minus x. When you have two things that almost look the same, they're both subtraction problems, but the order is switched, they're opposites of each other. If you think, for example, of, say, 5 minus 3 over 3 minus 5. Here, that would be 2 divided by negative 2, you would get a negative 1. Or if you had something like 7 minus 10 over 10 minus 7. Here you would get negative 3 over 3, which is negative 1. So when the top and bottom of your fraction are both subtraction and they're the same thing except the order is switched, that would have a value of negative 1. So x minus 2 and 2 minus x aren't the same thing, they're opposites. And when you have a fraction that's opposites and you cancel out both parts, instead of it being 1, you put a negative sign out front. So it would be a negative 1. When you reduce subtraction opposites. Notice if it was adding opposites, like x plus 2 over 2 plus x, When it's adding and you change the order, they're exactly the same. So it'd be positive 1. But if it's subtraction and you change the order, you can reduce it, but you put a negative sign out front when you do that. So keeping that in mind, let's look at a few more examples. Here we have 16 minus x squared over x squared minus 10x plus 24. So factoring the top part, that's a difference of squares. The square root of 16 is 4. The square root of x squared is x. We put a plus in one group, a minus in the other group. Now on the bottom, to factor that, it starts with x squared, so we put x at the beginning of each group. To multiply to be a positive 24 and add up to a negative 10, you would need a minus 4 and a minus 6, like that. So now we're done factoring, and we don't have anything that's exactly the same on the top and the bottom, but take a look at this group and this group. Those are those subtraction opposites that we talked about. Even though they're not the same, when you have subtraction opposites, you can cancel them out, but when you do that, you have to put a negative sign in front of the fraction. So that our answer here would be negative 4 plus x, oh, my writing's messy there, over x minus 6. So when you cancel out those subtraction opposites, you have to put a negative sign out at the front. Keeping that in mind, let's look at our next one. 9 minus x over 9 plus x. All right, so let's think about whether or not we can factor this. On the top part, you can't factor it. There's nothing you can do to factor 9 minus x. It's not 9 minus x squared, which would be a difference of squares. Here it's just 9 minus x. I can't factor it. What I like to do when I get something that I can't factor, I put a parentheses around it. The reason why I do that reminds me that I have to treat it as a group. And you can't, when you get to the reducing step, you can't reduce part of a group. You have to either cancel out the whole thing or nothing. So let's look at the bottom of this one. 9 plus x, I can't factor that either. So I'm going to visually put a parentheses around it to remind myself I have to treat that as a group. So for example, because these are both groups, I can't cancel part of a group. For example, I can't reduce the 9s by canceling them out because the 9s are part of a group. I can't cancel out the x's because those are part of a group. You have to cancel out the whole thing or nothing. In this case, it's a fraction that you can't reduce. Sort of like a fraction like 8 over 5. There's nothing except 1 they're both divisible by. Here, there's no factors we can reduce that fraction by. So that's the goal in section 7.1 is factor the top, factor the bottom, and then reduce as much as you can by canceling out common factors.